Welcome back, everyone, to another deep dive. This time, we're jumping headfirst into the world of artificial intelligence and machine learning.
Sounds exciting.
It is. Actually, it's more than exciting. It's one of the most transformative technologies out there right now. It's already changing the way we live and work in ways we can't even fully grasp yet.
Yeah, you're right. It really is everywhere.
And what's really cool is that one of you sent in the first chapter of a machine learning textbook and asked us to break it down. So consider this deep dive your personal study session where we unpack the basics of AI and ML and maybe have some fun along the way.
I'm happy to help unpack it.
Me too. Now let's start with the big picture. What exactly is artificial intelligence? Imagine you're trying to explain it to someone who's never even heard of it before.
Okay, well, I think a simple way to put it is that AI is all about giving computers the ability to kind of think and learn like we do. It's like creating systems that can perform tasks that usually require human intelligence. Things like solving problems, making decisions, or even recognizing patterns.
So it's not just about calculators crunching numbers anymore.
Definitely not. It's way more than that. It's like, think about all the things our brains can do that computers traditionally couldn't. AI is about bridging that gap.
I see. So it's getting computers to think more like humans.
Exactly. And here's where it gets even more interesting. AI isn't just this one monolithic thing. There are different levels of AI depending on how advanced it is.
Oh, okay. I'm curious now. Tell me more.
So the first level is called narrow AI. It's the most common type we see today. It's basically AI that's really good at doing one specific task. Like think about a spam filter for your email, or maybe even those recommendation algorithms that Netflix uses.
Right. It's like a specialist in one particular area.
Exactly. And then we have artificial general intelligence, or AGI for short. Now, this is the kind of AI we often see in sci-fi movies where machines can think and learn on the same level as humans across a wide range of tasks.
Oh, wow. That sounds pretty far out there.
It is, and to be honest, AGI is still mostly theoretical at this point, but it's a big goal for many AI researchers.
So it's like the ultimate dream of AI, creating machines as smart as humans.
Exactly. But then we have one more level, which is even more mind-blowing. It's called artificial superintelligence, or ASI. Now, this is the idea of AI that actually surpasses human intelligence in practically every way.
Whoa, so this is like computers becoming smarter than humans.
Potentially, yeah, but ASI is totally speculative at this point. We're not even close to that yet. And it brings up all sorts of ethical and philosophical questions. Like, what does it even mean to be intelligent? And what would our relationship with such super intelligent machines look like?
Those are some deep questions, but let's maybe bring it back down to earth a little bit and focus on something more concrete, machine learning. How does machine learning, or ML, fit into this whole AI picture?
Okay, so think of machine learning as a specific approach to achieving AI.
Okay.
It's basically letting computers learn from data without explicitly programming every single rule or instruction.
Okay, so how is that different from the way we traditionally program computers?
Okay, imagine you're teaching a kid to recognize different types of flowers.
Okay.
In traditional programming, you would have to give the computer a really specific set of rules, like if the flower has red petals and a long stem, then it must be a rose.
Right.
But with machine learning, you would just show the computer tons of pictures of different flowers, labeled with their names, and the algorithm would figure out those patterns on its own.
Oh, so it's like giving the computer a crash course in flower recognition, but without the tedious rule writing.
Exactly. And the best part, the more data you feed it, the better it gets.
So it's kind of like us humans. The more we experience, the more we learn.
Absolutely. It's all about recognizing patterns and making predictions from vast amounts of data. And speaking of the process, the textbook you sent in mentions a typical machine learning project involves several key steps. You want to run through those?
Yeah, I think that would be super helpful for our listeners.
Okay, so first you got to collect all the data you need. This could be anything, images, text, sensor readings, even financial transactions.
So it's like gathering the ingredients before you can bake a cake, right?
Exactly, and just like with baking, you can't just throw all the ingredients in a bowl and hope for the best. You got to prepare them properly.
Got it.
And in the world of machine learning, that's called data pre-processing. It's about cleaning up that data, handling any missing values, and basically formatting it in a way that the algorithm can understand.
So it's like prepping the data to be algorithm friendly.
Yeah, exactly. It's a crucial step because the quality of your data directly affects how good your results will be.
That makes a lot of sense. So what comes after all that prep work?
Well, then comes the fun part. You get to choose the right algorithm for the task at hand.
So how do you know which algorithm to pick?
Well, there are a ton of machine learning algorithms out there, each with its own strengths and weaknesses.
I see.
Some are good for predicting numbers, like, stock prices, and others are good for classifying things, like figuring out if an email is spam or not.
So it's about picking the right tool for the job, depending on what you're trying to achieve.
Exactly. And then You have to train that algorithm on the data you've prepared. It's like sending your algorithm to school, letting it learn from all that data.
Oh, that's a great analogy. So what happens after school is out?
Time for a pop quiz. We have to evaluate how well the algorithm has learned. We use a separate set of data it hasn't seen before and test it out to see how well it performs.
So basically, we see how well it can apply what it's learned to new situations.
Yes, exactly. And based on the results, you might need to go back and tweak things a bit, maybe adjust the algorithm, maybe try a different one. It's a very iterative process.
So it's like experimenting in a lab, constantly tweaking and refining until you get the desired results.
Exactly. But that's also what makes it so exciting. There's always something new to learn and explore in this field.
That's true. And speaking of learning, our textbook friend also mentioned something called scikit-learn.
Yeah.
What exactly is that?
Oh, scikit-learn is like a dream come true for machine learning folks. It's a popular Python library that basically gives you all the tools you need to build and test machine learning models.
So it's like a toolbox full of ready-to-use gadgets for machine learning.
Precisely. It simplifies a lot of the technical stuff so you can focus on the bigger picture. And speaking of the bigger picture, are you ready to talk about something really fascinating?
I am. Lay it on me.
How about we dive into how AI and machine learning are being used to tackle some of the world's biggest challenges, like sustainability?
Ooh, now that's something I wasn't expecting. This sounds like a fascinating twist. Tell me more.
I will, but you'll have to wait until the next part of our deep dive.
Ugh, you're such a tease. All right, everyone, we'll be back soon to explore that unexpected connection between AI and sustainability. Stay tuned. All right, welcome back to our deep dive into machine learning. Last time we talked about the different levels of AI and got a taste of what machine learning is all about.
It's pretty cool stuff.
It is. So now let's actually roll up our sleeves and dig a little deeper into how it all works.
Let's do it.
Okay, so one of the key takeaways from that first chapter is this whole idea of letting machines learn from data without us having to program every single step.
Right, like teaching someone to ride a bike by just letting them try it out.
Yeah, exactly. But how do we actually make sure the machine learns effectively? We can't just throw a bunch of data at it and hope for the best, right?
You're absolutely right. We need some guidance. And that's where these things called algorithms come in. Think of them like the coaches for our machine learning athletes.
Ah, okay. So the algorithms are like the instructors that help the machine learn from the data.
Exactly. They provide a framework for processing the data and figuring out patterns.
Gotcha. So are there different types of algorithms, kind of like different coaching styles?
Oh, absolutely. And just like you wouldn't use a basketball coach to train a swimmer, you wouldn't use the same algorithm for every machine learning task.
Okay, that makes sense.
So some algorithms are really good at predicting numerical values, like, trying to predict the price of a house or maybe how many customers will visit a store on a certain day.
Right.
And others are better at classification tasks, things like identifying objects in an image or figuring out if an email is spam or not.
So it's all about picking the right algorithm for the right job.
You got it. And there are actually a ton of different algorithms out there. But don't worry, you don't need to know them all right away.
That's a relief. So let's say we've picked our algorithm. What's next?
Well, before we let our machine loose on all that data, we need to do something called data splitting. It's a really important step.
Oh, okay. Tell me more about that.
Okay, so imagine you're a teacher getting your students ready for a big test. You wouldn't just give them the test questions beforehand, right?
No, definitely not.
Exactly. You'd want to make sure they actually learned the material. So in data splitting, we do something similar.
Okay, how so?
We divide our data into two sets. One is called the training set, which is like the study guide for our algorithm. And the other is called the testing set, which is like the actual test.
So we use the training set to teach the algorithm and then the testing set to see how well it's learned.
Exactly. It helps us make sure the algorithm can actually apply its knowledge to new data it hasn't seen before.
I see. So it's about making sure the algorithm can generalize its learning and not just memorize the answers.
Precisely. And speaking of preparing data, the textbook you sent in also mentions some other fancy terms like handling missing values, feature scaling, and encoding categorical variables.
Yeah, those sounded pretty technical to me.
They can be a bit targety, but they all fall into this thing called data pre-processing, which is basically just getting your data ready for the algorithm. Think of it like preparing your ingredients before you start cooking.
I like that analogy. Makes it much easier to understand.
So in the real world, data is rarely perfect. It might have missing values like blank cells in a spreadsheet, or maybe some values are measured in completely different units.
Right, like comparing apples and oranges.
Exactly. So data pre-processing helps us clean up all that mess and format the data in a way that the algorithm can actually work with.
So can you give me some examples of what that might look like?
Sure. Let's say you're trying to predict house prices. One of your features might be the number of bedrooms, which is a number.
Okay.
But another feature might be the neighborhood, which isn't a number, it's a category, right? Like suburban